All right, welcome back. So we should go through some example naming of molecular compounds. So I'm going to write a few up here, and let's see if we can name them together. So how about something like BF3, and maybe something like N2O5. That we'd already seen in all the NO compounds. Maybe something like ICL5, and maybe something like COCl4, and maybe something squirrely like P3O10. I'm not sure if that's real. And maybe one last one. What would be a good one? So ClO2. So go ahead and write those down. And if you want to, just go ahead and pause the video and just go ahead and name them all. And we can kind of unpause it and go through it together. Okay, so let's go ahead and start with BF3. So B is boron. There's one of them, but we don't say mono for the first one. F is fluorine, and there's three of them, so it would be tri. Fluorine becomes fluoride. So BF3 is boron trifluoride. If we went to, I should probably number these, right? So there's one. If we went to 2, so N2O5, there's 2 nitrogens, so that is dinitrogen. And there's 5 oxygens, so that's penta. But pentaoxide, right? That is kind of annoying, so we would just write pent oxide. We'd leave off that last A. If we went to ICl5, I is iodine. There's one of them, but we don't use mono for the first one. There's 5 chlorines, but here's where we do use penta, because pentachloride sounds totally hunky-dory. And if we go to CCl4, so C is, what element is C? Yeah, it's carbon. There's one of them, but we don't use mono for the first one. 4 is tetra, and Cl is chlorine, and we change the ending to IDE, so it's chloride. And let's see, are we at fifth one? So the fifth one, P3O5, so P is phosphorus, 3 is tri. So tri, so there's no problem with triphosphorus, right? The tri-P is easy to say. Phosphorus, though, PHOS, PHORUS, triphosphorus, not OUS. And then 10 is deca, but again, deca oxide is hard to say, so we say decoxide. And then the last one, this trips people up occasionally because everyone's used to seeing Cl as chloride, but the first element, right, is just the element name, so it's actually just chlorine, okay? And there's 2 oxygens, so it's dioxide. So how'd you do? Hey, you want another hard one? Let me give you another one over the page. All right, let's try some more challenging ones. So we got N3F7. We got CuF2. Oh, maybe we'll just do those two. So we could try and name these two, right? So we got 3 nitrogens, so it is tri-nitrogen. 7 is kind of a difficult one to remember. 7 is hepta, so it's hepta, and we don't have to drop the last letter because heptafluoride sounds totally fine. And then CuF2, you've got Cu is copper, and we've got one of those, so it's, we don't write mono for the first one. And fluorine, right, there's 2 of them, so it's di, and then we change the ending, so it's difluoride. And actually, if we wrote this on an exam, we would actually fail the exam. We'd get 50%, so one of them is wrong. So can you see which one is wrong and why? Pause the video and try and figure it out. Okay, I'm back. One of these is actually wrong, and I always kind of mix these up on the exam because when you're naming, right, you have to remember it's a molecule when you've got 2 nonmetals. And if you look at this one here, that's a metal and that's a nonmetal. So that's actually not a molecule, right? So it's actually ionic. And because it's ionic, then we have to remember the ionic naming rules. So we name the cation and then the anion. And fluorine, we remember, is a -1 ion. There are 2 of them. That's what F2 means. So we got -2 there. And copper is a transition metal, so its charge can vary. So we have to figure it out by looking at the other charges, and knowing that they cancel, we can figure it out. So 2 minuses means that copper, sorry, the word wasn't coming out, must be 2 positive. And because of that, we would name this as copper 2. Now, is it difluoride or fluoride? And the answer is for ionic compounds, we don't use prefixes. And the reason we don't use prefixes is that they only come together in such a way as the charges cancel. So there has to be two fluorines, or fluorides, I should say, to cancel out the charge on a copper 2, right? You can't have 1 to 3 because then you'd have a leftover negative. So copper 2 fluoride is totally fine. Copper 2 difluoride is not considered precise. And copper difluoride, right, is naming as if it were a molecule, which it is not. So be careful. There's quite a few molecules that, although we could name systematically, like we could name this dihydrogen monoxide, we actually almost never refer to it as dihydrogen monoxide. We call it water. And so there's a couple of others. So NH3, it looks like it should be nitrogen trihydride. This is actually ammonia. So cat P breaks down and forms ammonia, so it has that very pungent odor. If you've worked with the Bunsen burners in the lab, we're actually burning carbon tetrahydride, or more properly known, or more simply known as methane. And so these are three very common ones here. And we got a couple more, I suppose, just for fun. So SiH4 is related to methane, so it's actually silane. And pH3 is related to ammonia. We basically just substitute out one element for the one underneath it on the periodic table, and it is phosphine. And actually, phosphine was in the news fairly recently. They discovered it in Venus's atmosphere, and there's some thought that the only way you can get phosphine maybe in the air or in the atmosphere is if there's living organisms to produce it. So who knows?